Okie dokes. Hello, grade 12s. You are going to love this concept today. It's just too cool for words. We're going to see whether or not circles intersect in analytical geometry. We're going to be able to tell using the distances between their radii as well as the distances of their radii, comparing them, adding them, subtracting them. It's amazing. Let's consider this situation. Imagine you worked out using the distance formula. Let me get my little thingy jigs. If you worked out the distance between the purple big circle center and the blue smaller circle center, if you worked out that distance, it would be more or less the length of that glowy purple segment up at the top, right? Now, if you were to take the radius of each of the circles and add their distances together, in other words, join the radii together, can you clear as daylight see that the sum of the distance of the blue radius and the distance of the purple radius is smaller than the distance between the two radii when the circles do not intersect? So we can make a conclusion about this. For circles that do not intersect, if we call the big circle's radius capital R and the small circle's radius baby r or lowercase r, and the center of the blue baby circle is a B, while the aggrandized big circle, purple one, can be center A. If we look at the distance between A and B, so AB, that distance will be bigger than the sum of the distances. So R plus R is smaller than the distance AB for circles that do not intersect. Now, what if we decide to nudge these circles a little closer to each other? What if we say, hey, you come here, hey, you come here, and then they just touch. They touch externally, because the smaller circle is still on the external, the outside of the bigger circle. But here we go, they touch, and we know that they'll just have one point of intersection if they're just touching each other. Now let's have a look at the distance between the centers. So the distance between their centers, you can clearly see, will be exactly the same as the sum of the radii added to. Sorry if my voice was cut off there. So if we add the sum of the radii, capital R plus lowercase r added together gives you r plus r, it would be exactly the same as the distance between AB. What is the condition? When the circles touch each other externally. They just touch once, and the small circle is on the outside of the big circle. What about this scenario? What if purple is so eager to intersect with blue that it rushes on over and we have 2 points of intersection? Now do you see that the distance between the two centers is really, really small? So if we were to replicate that distance as I did up here, more or less, excuse my very amateur animations, I'm trying my best. The distance between the two centers versus the sum of the radii added together, I literally copied and pasted the blue radius and the purple radius, move them together, and you see that when these two distances, purple radius plus blue radius together, if they are added, they are actually bigger than the distance between the two centers. What is the condition? When the circles intersect each other. So if we want to write that down as a rule, we would say that the big radius plus the small radius together, the distance, remember we use distance formula to find the distance between 2 points. So if we use the distance formula to find the distance between point A and point B, and then we use the equation of a circle formula to get the distance of capital R, use the equation of a circle formula to get the distance of baby r, because that distance is given in those respective formulae. Then if you add them together, you should have this condition when the circles do intersect. Last but not least, what if the circles just touch each other, but now it's happening internally? In other words, if this baby blue circle pops onto the inside of the big purple circle. Let's have a look. The purple circle center is A, while the blue circle center is still B. The purple circle's radius is capital R, while the blue circle's radius is still baby r. Now let's have a look. If we were to get the distance between the centers, it would be this tiny segment AB. That AB distance is exactly the same as taking the big purple distance and scratching out the blue baby radius. So if you took the distance of the radius of the big circle and subtract the distance of the radius of the blue circle, you will get the distance between the two centers. Now, it is very logical, but I guess when you are in a stressful situation and you are a tad overwhelmed, it's easy to forget these four conditions. So please do your best to be able to sketch it or to be able to just memorize these formulae. I don't think it's that essential that you memorize these as laws you need to know off by heart, because it is quite logical, but it's important that you grasp why these rules are the way they are, and I hope that the animations and comparing the radii and the sum of the radii helped with that. Now let's jump into an example. So two circles are given. Look at how the entire formula of this circle has been given. Perfect. We know the center value would be -2 and +1, and we know the radius squared is 18. The other circle, the entire formula has not been given. They have failed to give us the y value of the center of the circle, but we do know that the radius squared is 72. So if you were to sketch this or try and imagine it in your mind, you can already know that this is going to be the bigger circle, while this one on the left is going to be the smaller circle. Right, they touch externally at this given point. So that's the situation where they're just touching each other, almost as if they were tangents to each other. Okay, now we need to show that the distance between the centers of the circles is 9√2 units. We know that when circles touch externally, that the sum of their radii is exactly the same as the distance between their centers. If you don't get that, go back to the video, so restart the video. So let's consider the distance between centers. That's exactly what the question is asking of us. However, we've got a major problem. We've got the center coordinate of this circle, but we do not have the center coordinates of this circle. So we can't work with the centers themselves. What we can work with is the radius of the big circle and the radius of the small circle. So let's look at 72 and 18. 72 represents the big circle's radius squared. So if we were to get the big circle's radius all on its own, we would square root both sides. Pop that in your calculator to help you get the simplest third form, and you can see that the length of the big radius is 6√2 units. We can do exactly the same for the small circle. We know that r squared is 18 because of the equation of the circle. So if we were to square root both sides, we'd get r all by itself. If you don't know, it's okay to use your calculator. Don't be ashamed. Do what you need to do. Pop root 18 into your calculator and you'll see that its distance in simplest third form is 3√2. Now I'm sure you can see these are like terms. 6√2 and 3√2 together gives you 9√2 units. And so you have shown that the distance between the centers is in fact the sum of their radii, which is 9√2 units. Now we're required to calculate this value of this variable b. It says hence or otherwise. Now I've obviously done or otherwise because you'll see in this video I haven't used this coordinate at all. So if you were to use the coordinate, you obviously can use the distance formula along with the center values of these equations in order to solve for b, but I know that the distance between these centers is 9√2 units. We've already calculated that. So if I look at the center of this circle on the left, the coordinate will be -2 and 1. And if I look at the center of this circle on the right, the coordinate will be +7 and +b. Now let's just slap these two coordinates into the distance formula. That formula is on your formula sheet, and this is one that's worthy of memorizing. So x, the difference between the two x values squared, added to the difference between the two y values squared. You can simplify that as far as possible, but we're going to need to solve for b. So what on earth do we make this distance formula equal to? Well, the distance between the two center points has already been calculated as 9√2 units, and so we can substitute 9√2 to be equal to that whole big cumbersome formula. Let's square both sides to get rid of the square root and chuck everything over to one side of the equation to make a trinomial. Now I'm going to be honest with you, I was super lazy to factorize, so I just popped this into the equation mode of my calculator, and with my a value 1, b value -2, and c value -80, and this is what it gave me. B equals 10 or b equals -8. Now remember, it said b must be a negative number, so b must be -8. Let's cross out b equals 10 as a final answer, and now you are ready for exercise 7.4, page 294 for homework. Enjoy.